What's up, guys? I'm back. Justin Linder here, Linder Power Systems, lpsfab.com. I was away for a little bit. I've been pretty sick, and then with the Christmas break and stuff, it's been a little hard to get any videos done, but I'm still a little sick, so bear with me. But I'm going to start getting after the cylinder head here. So first thing we got to do is tear this thing down. I was messing around with my spring compressor here. This is my old spring compressor, and it's kind of seen better days. This spring assembly doesn't work very well anymore, and it's just pretty cumbersome to use. So I started doing some digging on the internet, and the internet being a wealth of information, I came across this setup. So basically, let me kind of show you guys here. So this is considered a bolt-on remote actuated because the handle doesn't have to be attached to the compressor, spring compressor, and it bolts down to some of your cam cap bolt holes, and this is separate from your handle. This handle can move on this rod, and this compressor section can move on the rod. So that's pretty handy. And then I found this guy, this Valve Master tool. This thing is awesome. So basically it's got a guide for your exhaust valves, and then this is the right size for your intake valves, and this is specific to the 18T. And it's got some magnets in here. And basically, so this is a guide, goes down where your bucket would usually go, and guides this to the center of the valve. This has got some rare earth magnets in there that basically suck the keepers out. But the coolest part is you flip this thing over, and you have this little spring-loaded gizmo here. And you can kind of see those little valve keeper pockets, and then the bottom side of this has some little guides, and basically you can stick your valve keepers in here, lock them in with that, and then you just punch it back down on top of the keeper, and or the retainer, and the keepers just like automatically get locked into place, and it's pretty freaking sweet. No more fiddling around trying to go, between your little socket thing and trying to get those keepers in place. And I've already tested it, and it works pretty good. So I'm going to go through disassembling this head. Well, the rest of it, I've got 3 valves done here. I'm going to do the rest. And basically, you're pushing the valves against whatever surface is under the head. So I went ahead and I kind of put some towels down, and this is a wood-topped cart, so I wouldn't damage the valves. Sorry, pardon my sickness. But I'll try to do a close-up here and kind of show you how this thing works. Let's see, this side might be better. So, you take your guide, you drop it in the valve pocket that you're going to do, and then you can kind of see which way your keepers are faced by the split line in them. This one's pretty much like that. And then you basically use this remote compressor. And I've got this clamped down to the table so that it doesn't roll over on me, because it does take quite a bit of pressure to do this. But basically you just compress this thing. And looks like we got one keeper, but not the other. So we'll just do that again. And there it goes. There she is, out. There's your retainer. And your keepers get sucked up by that little magnet in there. They give you this little 3D printed tool to get the keepers out. But that's it. So pretty sweet tool. Makes disassembling the head really fast, And then if you want, I can show you guys how this works. So you flip this guy over. Oh, you gotta put the retainer in there. Drop that guide in there. And then you stick these little keepers right up against that center shaft there that's spring loaded in those little pockets. Make sure they're faced the right way. So hopefully you guys can see that. And then you lock them in with this little guy. So that goes down on top of them. So it's locked in. And then you just punch them back in. It's pretty freaking awesome. That didn't seem like it worked. Nope, got caught up funny. Not an exact science apparently, but we'll get there. Alright, got this loaded back up again. Let's try that again. Sure doesn't seem like it worked. So now it's not working for me for some reason. Maybe I'm not doing it quick enough. Could also be that the valve's sitting too low, but we'll see what we can do here. Started to get one in, but it didn't get them both. Alright, we're going to try again here. I think the problem probably is that the valve is, since there's nothing under this cylinder, I think it's sitting too low and I can't get it to compress far enough. So we might have to, especially with aftermarket springs that are a bit stronger, we might have to put something in the combustion chamber to hold that valve up a little better. But anyway, we'll figure that out down the road. So I'm going to continue disassembling this head and we'll go from there. We'll worry about reassembling it later. But you can watch how fast this is. So it seems like it usually gets one keeper and then you got to go back and get the other one. And this head's been sitting around quite a while, so I'm wondering if their keepers are kind of sticky in there. This was working perfectly until I turned this video on. There it goes. Maybe you just have to have the magnets face the right way. Let's see, keepers are vertical, so maybe that direction. Yeah, see, that one came right out. So it seems it is kind of important to have the magnets faced towards the keepers. Yeah, it seems to work really good then. I have to say I've never had a head that's this easy to disassemble. So this one, the actual bracket for this thing is in the way of getting the spacer in there. I might try to just do it without it. Let's see here. So keepers face that way. I'm just going to manually center it up on the retainer here. Yeah, maybe that's not such a good idea. Alright, so I'm going to have to pull this off and get that spacer in there. Or maybe I can just loosen it enough to swing it out of the way a little bit. Yeah, there we go. So we'll drop that in, bolt this back up. Snug it up a little bit. I just want to snug it up to make sure it's not deforming any of the head surfaces or anything. Okay, so keepers are faced that way. Oops. Let's see what we got here. Got one keeper. The other nice thing about this is you don't lose keepers. They don't go flying across the room or anything, which is a big benefit. Seems like it likes to do one keeper at a time on the way out sometimes, but that's that. So there it is. All the exhaust valves are done. Gotta swing this back out of the way. But really, really simple. I really like it. Oh, this spring compressor is a SP Tools Sheely Products Inc. Hopefully you can read that. And there's the model number 91400B. It's about 125 bucks. Worth every penny. So I'm going to go ahead, I'm going to flip this head around and do all the intake valves, and then we'll start pulling the valves out and all that. So I'll do that. Alright, that's the last one. So pretty straightforward. That would have taken me a lot longer with the old spring compressor. Pretty sweet. So I got all these keepers bagged up. I also pulled all the followers out, and I have them sitting in some ATF transmission fluid because it's a detergent oil, and it'll kind of help get the varnish off of them and degrease them a little bit. But we are going to go through cleaning the heck out of these things later in another video probably. Okay, so we're going to pull the valves out of here. My piece of paper. Now, most people are going to tell you to keep these all numbered and where they came from and all that. I'm not going to worry about it because I'm going to go through and lap each one of these in and basically reseat them after we clean them and everything, and work on the cylinder head. And this is all stuff you can do by hand. As long as you're staying hydraulic lifter, and even if you're going solid lifter, you would just have to make sure that you set your valve lash correctly. If your head's already solid lifter and the valve lash is already set, you could number them, but most likely you're going to have to reset that lash anyway, because when you reseat them, when you lap them in, they're actually going to get slightly closer to the head surface. So you're going to want to, at minimum, double check that lash. I'm kind of feeling these as I pull them out to feel how sloppy that guide is, and they all feel pretty snug. So, like I said, I think this head's in pretty good shape. So I don't think it's going to need guides. In fact, I'm not going to put guides in it. I'm going to run it the way it is, because this isn't exactly a huge performance build anyway. So, kind of doing it like the normal garage mechanic would do it. It's it is a performance build, but it's nothing crazy. So, not a big deal. Now I'm unsure if these ADR valves are actually sodium filled like the 1.8 T's. I kind of guess that I would guess they're probably not. And sodium filling helps the valves stay cooler. That one felt a little grimy. But I do have some 1.8T valves I could probably use. I might think about that. If any of you guys know if these NA heads maybe don't have the sodium filled valves for sure, let me know. Because it might be a good idea to change those to some of the factory valves. Just for cooling purposes, not really for flow or anything, because the stock valves don't flow very well anyway. But so basically there's that. I'm going to pull the valve seals out of here. And then we'll be on to doing the next thing. These are just some cheap valve stem removal pliers. Amazon something or other. You just want to be careful you don't hit the surface where the buckets ride when you're pulling these out. Be pretty careful. Obviously it's going to be a little tighter on the intake side. These come off pretty easy. Barely fit. Alright, this head is basically completely disassembled. So I'm going to start cleaning. You can take this to a shop and have it ultrasonically cleaned. But since I'm going to be doing so much grinding on this head and port work and stuff, I don't really see it necessary to do that, because I'm going to grind out most of the carbon that's really stuck on, and the rest of it's just grease. So I'll just degrease it really good, and then start grinding on it, and then we'll clean it again after we're done. So on to that. Okay guys, so I'm over here at my sink. I'm just kind of degreasing this thing really good. For those of you that don't know, if you have a dollar store near you, Awesome Orange is actually awesome. It's this degreaser from the dollar store, $1 a piece, and this stuff works killer. So I'm just going to hose this down and let it kind of soak and maybe scrub on a few spots, and then get it kind of somewhat clean, and then we'll start doing some porting. The other good thing about this degreaser is that it doesn't make the aluminum oxidize like a lot of the foaming degreasers and stuff does. You know, where it makes it all, I don't know, like after it's clean it kind of oxidizes really fast and gets kind of that white looking substance on it. This stuff doesn't seem to do that, or at least not as bad. You can see the quick once over with the Awesome Orange and a little bit of scrubbing and some hot water, and it's already pretty clean. Obviously it can use some more, but for our purposes this is probably good enough for now, because we're going to be cleaning this a couple more times before we're done. So we got a lot of grinding to do and a lot of cleaning of grinding materials out of this thing before we're finished. So I'm going to call that good enough for now. A lot of this stuff's going to get taken off during the grinding process. So yeah, we'll move on to that. I'm going to dry this thing off with air really good, set it up on my table, and then we'll be going. Okay, I'm getting set up to do some porting here. I wanted to show you guys something though. I had a bunch of 1.8T turbo motor valves sitting around from an old head that was bad, and I pulled all the guts out of it. But I noticed that let's see if I can show you this. So this is the exhaust valve from the ADR head, which is the NA head in Germany, the NA 1.8. And then this is the 1.8T. And upon first inspection, they look the same. And I was kind of wondering if they were sodium filled, so I was weighing them and stuff to see if I could tell a difference. And they weigh the same, so I think they're both sodium filled. But if you look close, the keeper height is actually different. So I think what Audi did was, instead of changing spring part numbers and retainer part numbers and everything, they didn't need as much spring pressure on the NA engine because it's not boosted. So what they did was they just offset that keeper down to give themselves a little bit more seat pressure on the exhaust valves. With that being said, I'm pretty sure that all the aftermarket products, all the aftermarket springs and things are made for the 1.8T valve. So if I was to use the ADR valve, I wouldn't get as much seat pressure as those guys advertise So what I'm going to do is I'm going to go ahead and use all of the 1.8T valves that I had, and I'm going to shit can these ADR valves. I'm sure they're perfectly good valves, but again, we don't have probably as much seat pressure, and you definitely want a lot of seat pressure on the exhaust valves, because that's, especially with small turbos, that's where most of the pressure happens, and where you could possibly hang valves open is in the exhaust manifold. So unless you're running a ton of boost, with the big turbo, you're probably not going to see an issue on the intake side, especially with the size of the intake valves. But on the exhaust side, the valve's a little bigger, and with the small turbos, you're going to be getting, you could get as much as 2-to-1 pressure ratio versus your intake manifold pressure. So, that's obviously at a point where you'd want to be upgrading things to create more flow on the exhaust side. But this 1.8T valve is going to give us a little bit more seat pressure, so those are the ones I'm going to go with. So I just thought I'd point that out to you guys. This is what doing all that paying attention to detail gets you. You start noticing little idiosyncrasies in what the OEMs did, and you kind of have to be aware of that stuff, or else you could end up putting like an improper valve in there that's not meant for the turbo motor, and the aftermarket parts aren't designed around it, and you could have a problem or a failure at some point because of that. The intake valves are all the same. The stem height was the same, so I'm gonna stick with the valves that were in it, because they're in pretty good shape. So anyway, I'm gonna start on the exhaust ports here, and what I'm doing, let me see if I can show you guys a little better. What I'm doing is I got a piece of pipe that I'm going to use to build my header, and I noticed that the ID basically fits the gasket exactly. So what I'm going to do is I'm going to use this gasket to scribe some marks as a visual reference, so that I can bring these exhaust ports out a little bit to meet that diameter, basically. So I probably don't need to bring the exhaust ports out that large. So what I'm going to do is I'm just going to open up the face of them and make sure it's a smooth transition. And all I'm doing is using a scribe, pointy sharp scribe, to scribe a line around the inside of the gasket. And I'm trying to kind of hold the gasket centered where I think it kind of centers up on all the studs. And this is just going to give me a visual reference to bring those ports out to. Typically, you don't want to open up ports too much, especially in engines that are already designed as somewhat of a performance engine. A lot of head porting guys get into, well, not really head porting guys, but I guess novices, head porting novices. They think that just opening up the port as much as possible is ideal, and just making it a big ol' port. And on the exhaust side, it's not as critical, because you're just trying to get air out. But on the intake side, you can definitely go too big. And one of the reasons is that I guess most really good head guys say that the ideal port is the port that is just large enough to not decrease velocity. So basically, you're bringing a port, you're shaping a port really in a way where you're increasing flow and velocity without basically increasing the area so much that you start losing some of that velocity. So basically, you don't want to go too big. Some ports could use opened up. I think that the small port 1.8Ts are they're pretty small, but those could probably be opened up to like the big port style head. I mean, you could do the math, figure out the area of the valves and when they're open and all that, and figure out the port dimensions and things like that. But you know, going by what the factory already figured out, I think that the big port head is probably more ideal for a performance application. Small port head was more designed for a torquey engine that makes a lot of torque down low. So they had they obviously paid more attention to velocity than overall flow. But we're going for a performance application, so what we want to do is basically smooth things up and you know, without going too big, but you know, make things transition well, make things flow well, and pay attention to some of the spots that might not you know, be, I guess, the obvious. Like a lot of people work on the bowl shape right behind the valve. But what's funny is that the inside radius, the radius that cuts right back from the valve on the bottom of the port, is actually more important than the outside radius, which is kind of counterintuitive. So we'll talk about some of that stuff. All right, guys. So that video is getting pretty long, so I'm going to stop it there and go into the porting in the next videos. It's just, you know, I'm trying to keep these videos, you know, within reasonable lengths so that they're not, you know, like a novel to watch, while still giving as much information as I can in a short amount of time. But anyway, if you're liking these videos, if you like what I'm showing, and you like learning this stuff, please subscribe, and we'll go into the porting videos next. Yeah, anyway, see you guys next.